Hi, I am Ammar, metric number DE220129. I am from group 4. So my group consists of another 4 person, which is Kamila binti Abdul Rahim, Wan Afif Amjad, Aziz Tazri, and Muhammad Nazmi. So I will be starting on with the first question. So the first question asks us to draw the bounded region bounded by these two equations. So I have also find the intersection point of these two equation, which is the x1 and x2. And then this further down is just code to display the graph result. And then on the right here is the result that we got. The right one is the x square value or paraboloid. And then the blue one is 2x. And then lastly, the light blue is our bounded region. So moving on to our first question, 1A, is to find the area of the bounded region. So to find the area, we need to do a double integral of the equation. But in MATLAB, it is easier. We can just use this integral function, and then we just plug in the item that it needs, which is the function that we want to integrate, and its limit, which is 0 to 2, according to our x1 value and x2 value. And then this code is just to display our result beautifully. So on the right here is our result. So the area of the shaded region is 1.333, which is similar with our manual calculation. We got the answer here is 4/3 unit square.
Hi, my name is Kinda Nita Ibrahim, metric number DE22086. So I'll be explaining related to the question 1B, which is finding the surface area of a solid. So from the question, I define the original Cartesian function, which is from the z equals to x squared plus y squared. So I get the fx, which is 2x squared, and then the fy, which is 2y squared, and the fc is 1. And then this is the function. And then second, I need to convert this function to the polar coordinates, which I replace the x into r cos theta and y into r sine theta. And then I define the integration limit, which I define the r value, which is 2 to 4, and the theta value, which is from 0 to 2 pi. And then I perform the double integral using the integral to syntax of the MATLAB, and then I just plug in all the function, and then I could get the final answer, which is 170.2435, which is same as the answer at the manual calculation. Thank you.
To the previous presenter. Now I will continue a good presentation video with the next question, which is question 1C. First of all, my name is Wan Afif Amjad and my matrix number is DE220817. So for this question, we need to find the volume of the solid, which is the solid of z equal to square root 4 minus x squared minus y squared. So first of all, we will declare which is we're using the function equal to the equation of the question, which is square root 4 equal to x squared 4 minus x squared minus y squared. And then we'll change from the Cartesian coordinate into the polar coordinate because the shape given is in a circle. And then after we change it into the polar coordinates, we'll declare the interval for this question, which is the interval for this shape, which is for the r, it is from 0 to 2, and the theta, it is from 0 to 2 pi. After we'll declare the interval for this shape, we'll perform the double integral, which is we use the function volume equal to. First, we will integrate the first one in this bracket, which is we'll integrate the polar function. The polar function is we already declared before here, which is equal to square root 4 minus r squared multiplied with r, with respect to r, from r minimum to r maximum, which is r minimum is 0 to 2. And then after we'll integrate this equation, we will get the answer, and then the next answer we will integrate one more time. But for this time, it will be with respect to theta, from theta minimum, which is from 0 until 2 pi, the theta maximum. So after we run this simulation, we'll get the answer, which is the volume of the solid is 16.7552, which is same with the manual calculation. Thank you. That's all from me.
Hello everyone, my name is Asitaz bin Fazli. Now I'm going to continue our presentation by answering question 2A. So based on the manual calculation that we have done, we can find the dx, dy, dz to be 0 to 4, 0 to 4 minus x, and 0 to x squared plus 6. So from this interval, we need to compute it into the formula for volume, which is triple integral 1 dv. The dv can be substituted into dz, dy, and dx. So based on this line of code, first what we need to do is to declare the x, y, z variable that we're going to use. And then by using this formula for volume underscore 2a, we apply the triple integral like this. And this one is from this formula here. And then for the z, we apply the 0 to from the minimum to maximum interval. And then for the y, we did the same, minimum to maximum. And for s, we apply the same thing, 0 to 4. So this will give the answer, and then this is to display the answer from this line of code. So to plot the region, to verify whether our drawing is correct, we use this, which will create the region in the first octet. So for this line of code, we need to insert it for it to clip the value outside of this plate to have this arc over here. So for the figure, this is used for the coloring, the labeling, the title, and the color scheme for the color bar. So when we run this line of code, we managed to get the volume to be 69.333, which is the same for our manual calculation. So that is all from me. Thank you.
Hello, my name is Muhammad Azmi and I will prove our manual calculation using MATLAB. So this our question is question 2b. So this is the question. We need to find region bound between cylinder in the first and second octet. We need to know that cylindrical coordination we use here is radius, theta, and z. After we find the value, we need to insert in this formula, and we get 6 pi unit cube. So we need to prove using the MATLAB. So this is our code we use. So syntax is the r theta z, and this is the formula for this question. So we use triple integral that same with this formula. 1 z 1 for 1 here is the value of integration that we find. So second, it will integrate with radius, and then we integrate with theta value. So after we run this code, and we get this answer 18.8496. This is value of 6 multiplied pi. So it's the same with our manual calculation. So that's it for question 2b. Thank you. So this is our answer for question 2c, and we need to prove using the MATLAB. The question asks we need to find bounded above the sphere and below by the cone, and we need to use spherical coordination that you need to find rho, theta, and phi. So we find phi using p formula, and we get 0 to 9. Pi is because it's 4 others, so 0 to pi over 2, and we can find our phi using the equation, cone equation. But first we need to convert that x and y into spherical coordination, and we get pi over 4, and we fill in this in formula, and we get 111.79 units cube. And this is our code for this solution that we use. Our syntax is rho, phi, and theta. Our formula is you use triple integration, spherical, that raw power of 2 multiplied by sin phi. So you will first integrate with raw value. After that you will integrate with phi value, and lastly the theta value. So after we run this, we will get the answer is the same answer with value manual calculation, that 101 11.79. So that's it. Thank you.